Hey everyone, welcome back to CAD Tips and Tricks with Smart Design. My name's Nick. I'm a senior design engineer here at Smart. Today we're going to talk about how to build parting lines into your model, and more specifically, how to build planar parting lines. So let's say you're designing an injection molded plastic part, but you're not using traditional solid body modeling that has a lot of extrusions and planar faces, where you can just use the draft tool and apply it to those faces. Instead, you're using surface modeling, you're building a more organic shape. You still have to ensure that that part is moldable and you have a really clear considered parting line. To walk through this, we're going to use basically just one big surface that's mirrored over to talk through how you actually implement this into your model. So to get into the master model here, the first thing I'm going to do is actually build my parting line. Now, the parting line is going to be used to create a reference surface that all of your actual model surfaces are going to attach to and reference. So what that means is your parting line needs to be built really early on in your model. So that's going to be the first thing we tackle here. Now for this, it's really simple. It's just a spline. It's a spline on this plane, and we're going to use that as our base for our reference surface. Now to build that reference surface, you can do it in a lot of different ways. You could just extrude that parting line down and then draft that surface using a traditional draft tool. I'm actually going to use it today doing a sweep. And so this sweep is just a line, and that line has a generic length, but that line is drafted on that vertical axis by 1.5 degrees. And so this angle right here is what's going to be driving the model. That's going to be the one I change if I want to change the draft angle of my surface. So I'm going to say okay to that. That line is swept across that profile, maintaining that 1.5 degree draft. And now when I build out my actual surface, and I build out these sections here, every single section is going to have a surface tangent relationship to that sweep. And so if I come in here and edit this spline, you can see this tangency handle, surface tangent. The middle one, surface tangent, and the last one is going to be surface tangent to that sweep. Now, since all of the splines that we're using for the construction of this surface are surface tangent, that means that once we build this big four-sided surface, we can have a tangent relationship across that whole edge with the sweep. And that's what we're looking for. We're trying to push a draft across the entire edge of that surface. Now I'm going to roll through the rest of the model, just closing out the volume. And when we come look at the handle, if I turn off those edges, you can see that there's clearly a tangency break, a sharp edge between the top and bottom of this surface when I mirror it over. And that's what we're looking for. And if I do an actual draft analysis here at 1.5 degrees on my top plane, you can see we have a really clear, crisp parting line going through this whole model. Now, of course, if I put the threshold to something like 20 degrees, you can see that we're not drafted enough, but anything less than 1.5 degrees, and we're good to go. And so you're always going to just go back to that sweep, go back to that reference surface, change that dimension, and that's how you update the draft for your model. That covers it for today. Thanks so much for joining, and I'll catch you at the next one.